Hello, everybody. My name is Liam Howarth, and I'm a computer engineering student at the University of Oklahoma. I want to make a series of videos about all the convergence tests for infinite series. So we're going to start with the nth test for divergence. And this one's pretty simple and I feel pretty intuitive. Uh, and this is always the first one you should check and the easiest to actually apply. So the nth test for divergence, you want to take the limit of a sub n, and if that limit does not equal 0, uh, you know that the series a sub n, or the summation, I should say, a sub n will always diverge. And I'm going to walk you through an example, but I feel like this is pretty intuitive because, for example, if you're just adding 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 on forever and ever, you're going to know that that's obviously not going to converge to a single number. That's going to just equal infinity. That summation is going to equal infinity. But let me walk you through this example. We have an example of summation n equals 1 going to infinity of n over n plus 1. So you're going to set it up as limit as n goes to infinity, n, where we call this a sub n, of n over n plus 1. So you take the limit as a sub n goes to infinity, as n goes into infinity. Then you're going to solve the limit. In this case, it's pretty simple. N on top is going to become arbitrarily large, and n on the bottom is going to become arbitrarily large as well. So this 1 right here is not going to matter whatsoever. We know this is just going to grow to 1 over 1. Or you can think of it as a very large number. Infinity is not a good thing to write, so like 99999 over 99999 plus 1. But as more and more nines get added, this 1 is going to matter less and less. So much to the point where you can just, when you end up having 100 nines, it's going to be pretty much the same number on top and bottom. So we call this equal to 1. So we found that this limit is equal to 1. And 1 does not pass the nth test for divergence, or you might say it does pass because it diverges. We found that if limit as n goes to infinity of a sub n, where we called n over n plus 1, we found that it does not equal 0. In fact, in this case, it equals 1. So I want to go over some more rules of the nth test for divergence. If the limit is not 0, the series diverges. That's the main thing. You're going to check if the limit is not 0. If it's any number other than 0, the series is going to diverge. If the limit does not exist, we also say that the series diverges. And if the limit equals 0, the test does not necessarily mean that the series is going to converge. It is what we call inconclusive. So it may converge or it may diverge. And in this case, we're going to just have to choose another test for convergence to test this series. And a good example of this is a harmonic series, which is summation n equals 1 to infinity of 1 over n. This is a harmonic series. If you expand it, it's going to be like 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, etc. And this series is decreasing, and in fact, the limit as n goes to infinity does equal 0. But for reasons we can get into, the harmonic series actually does diverge, and it does not converge. So this is a good example of the third rule of if the limit equals 0, the test is inconclusive, where this harmonic series, you take the limit as n going to infinity, it does equal 0, but the test does in fact diverge. So that's just one example of where this test is inconclusive and in fact does diverge. In the next video, I will go over, we'll probably do the geometric or p-series test. Thank you.